Sathyabama Institute of Science and Technology.
I am Dr. Vidya, Assistant Professor, Department of Mathematics, Sathyabama Institute of Science and Technology. I just come here to present about definite integrals. As you all know the properties of definite integrals, I just want to show you certain properties which are very useful in doing our problems. So let us just first see what are the properties in definite integrals. See, these are certain properties in definite integrals which you are all aware of. Actually, property number 1, this is just denoting integral a to b f of x dx is equal to integral a to b f of z dz, which shows that for whatever the integrand you are going to have, you can just, we are evaluating that and we can have any variable inside it. That is what. The second property, that is property number 2, what we have written here is integral a to b f of x dx is equal to minus integral b to a f of x dx. It shows that whenever you just reverse the limit, we can just have one negative sign. So that negative sign is observed whenever the limits are changed here. The next property, property number 3, integral a to b f of x dx is equal to, you can write it as integral a to c f of x dx plus integral c to b f of x dx. The fourth property states here integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, which is a shifting property, and this is very useful in doing our integral problems. And fifth property, it is integral minus a to a f of x dx. It can be written as 0 whenever your integrand f of x is odd. That is, f of x is odd means if your f of x is equal to minus into f of x, then we f of x, we are writing x as minus x, replacing x as minus x. So f of x, we write f of minus x. So f of minus x is equal to minus into f of x, means it is an odd function. F of minus x is equal to f of x means it is an even function. So depending on that, we decide here, that is 0 whenever f of x is odd, and 2 times integral 0 to a f of x dx whenever it is an even. F of x is an even function. Now I just present you here in this PPT like a problem on based on this definite integral. So let us take this problem. What we are evaluating here is integral 0 to pi by 2 log sin x dx. So now all of you know how to integrate it without limit. Whenever we say anything without limit, we just say integral. Whenever we put any limit over it, then we are able to find the value for that integral, which we say definite integral. So let us just look upon this problem. So first of all, you just assume whatever the integration, whatever the problem given to you as some I. So I is equal to integral 0 to pi by 2 log sin x dx. Just I mark it as 1 here for your reference. Then you just say what property we are going to make use of here is nothing but integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, which we are going to make use of that in the problem. So now let us replace x as pi by 2 minus x. So pi by 2 minus x. So that we are able to see that sine of 90 minus x is nothing but cos x. You can write integral 0 to pi by 2 log cos x dx. So mark it as 2. I just mark it as 2 here in this slide. And now we just remember what we have written in 1, which is nothing but your integral I is equal to integral 0 to pi by 2 log sin x dx. Now 2 is nothing but integral 0 to pi by 2 log cos x dx. So on combination of this or adding 1 and 2, what we are about to get here, that is 2 integrals are added. To the left hand side we get 2i. To that right hand side what we are having here, integral 0 to pi by 2 log sin x dx plus integral 0 to pi by 2 log cos x dx. As you all know a property on logarithm, that log a plus log b, we can write it as log ab, product. If it is an addition, we can just write it as a product. So it is called a product rule. So let us just impose that here so that we are able to get log sin x into cos x dx. So now you all know sin x into cos x is nothing but sin 2x by 2, because 2 sin x cos x is sin 2x. So let us put it here. So you get log sine 2x by 2 dx. Now whenever we have log a by b, as you all know, it is a division rule in logarithm. That is what you will write here, log a by b is log a minus log b. So log a minus log b, as we are presenting here as 0 to pi by 2 log sine 2x dx minus 0 to pi by 2 log 2 dx. So here it is 2y. Now, as we cannot evaluate log sine 2x directly, so what we are doing here is we just assume that 2x is equal to some y. So 2 dx will become dy. So when x is 0, just we take care about the limits. So x equal to 0, then y will automatically become 0 here, and when x is pi by 2, y is becoming pi. So we are understanding that. So let us impose everything here so that we are able to get this solution, integral 0 to pi by 2 log sin x dx for the evaluation of integral 0 to pi by 2 log sin 2x dx. Mark it as 4. Now you substitute this equation 4, whatever we derived here, whatever we attained here, in 3. So we are able to have a solution 2y is equal to I minus pi by 2 log 2. So now you bring all I together. So it will become 2I minus I to the other hand. So it will become I. So I will become minus pi by 2 log 2. What is I? It is nothing but our question. So now we are in the end of the problem, that we are derived to the solution. What is it? Integral 0 to pi by 2 log sin x dx is equal to minus pi by 2 log 2. That is our solution. So now let us go to the next problem, where we are again just doing the properties of definite integral here also to make you very clear. So evaluation of integral 0 to pi by 4 log of 1 plus tan theta d theta. So how we are going to evaluate it? As usual, let us consider I is equal to integral 0 to pi by 4 log of 1 plus tan theta d theta. Now what we are going to do here is just you replace this upper limit, which is pi by 4, as pi by 4 minus theta. So what will happen? It will become log of 1 plus tan of pi by 4 minus theta d theta. Now actually when you have tan of a minus b, what is tan of a minus b? Let us note it here. Tan of a minus b is nothing but tan a minus tan b divided by 1 plus tan a tan b. So let us make out here tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 into tan theta. So tan pi by 4, as you all know that it is tan 45 is 1. So we just put here 1 minus tan theta divided by 1 plus tan theta d theta. So what will happen now? Just to take LCM over it. So you will be getting log of 2 by 1 plus tan theta d theta. Now 2i, again we add both I, so it will get to 2i, which is nothing but equal to 0 to pi by 4 log of 1 plus tan theta d theta plus integral 0 to pi by 4 log of 2 by 1 plus tan theta d theta. Now as you all know the logarithmic property, that is log a plus log b is log ab. So we are writing log of 1 plus tan theta into 2 divided by 1 plus tan theta, combining a into b. So what will happen? 1 plus tan theta will get cancelled. So you just have log 2 d theta. We retrieve to this one. So now log 2 is a constant, we take it outside. So integral 0 to pi by 4 d theta. What is integral d theta? It is nothing but theta. So we just put theta and apply the limit. We will get pi by 4 log 2. So 2i is pi by 4 log 2. But now you bring the 2 there. So you will get I equal to pi by 8 log 2, where we are giving our result for the question integral 0 to pi by 4 log of 1 plus tan theta d theta is nothing but pi by 8 log 2. I think all of you can understand the properties and how it is being just the properties are involved in the problems. Thank you.